Hello everybody and welcome to the video on confidence intervals sample size for a population mean. Now in this video or in the instructional video you were introduced, and in your textbook reading you were introduced to a t distribution, and you were asked to find a t critical value. So I'd like to show you how to use that using StatCrunch so that you don't have to use these crazy tables. So they do provide these tables for you to use. I don't recommend using them, but you can if you so choose. But I'll leave that up to you. So let's see. I can get rid of this window here. So all right, so let me come back over here. Let me make this a little smaller, and let's go ahead and take a look at StatCrunch. And I'll go ahead and make that a little smaller too. All right, so we want to go the other way with our t distribution, and this is going to work a little bit similar as the normal distribution in finding the z alpha over 2s. So this is going to find, they'll ask you right tail, upper tailed, lower tailed, middle area. And my intention is not to do this whole homework assignment for you, but to get you started with this. So let's go over here to calculators, and let's take a look at this t distribution. All right, so notice over here we're asked to find an upper tail. So our degrees of freedom, we are given 5 degrees of freedom. Here's a hint. Notice if they give you the sample size, you have to subtract that by 1. So we'll come over here and change this to 5 because we're given 5 degrees of freedom. And I'm just going to flip this around because we want an upper tailed, and we want that area to be 0.025. So I'm just going to come over here to this side, 0.025, and I am going to click compute, and notice that it says that we come up with 2.571. Notice it asks us to round to 3 decimal places. So we can come over here and go 2.571. Check our answer. Hopefully we get the green box. We do. And then we can proceed to doing the t value here for an upper tailed area of 0.05 with the degrees of freedom of 14. And again, you just come over here, change this to 14, and we will change this to 0.05. And again, we want an upper tailed. Remember, if it says a left tailed area, you'll have to switch this. All right, so we go ahead and click compute, and we get 1.761. So that should help you out on finding the critical values. All right, so the next one that I'd like to take a look at is to compute confidence intervals for a population mean. Okay, and so I would like to come over here and maybe take a look at, I had one in mind. Let me find it. Yeah, let's take a look at this one here. All right, so a survey was conducted and asked this many people the books they read. Okay, so here we're given some mean and our standard deviation. So now we want to do our 99% confidence interval. So we can come over here to stat, calculators, stat, and then we want to come over here to t-stats. And we have a one sample, okay, t-stat, one sample. And so we have summary data. All right, so our sample mean right here is 13.4. Okay, and our sample standard deviation S is 16.6. And the sample size, we are told, is 1018. Okay, so now we come down here just like we did. We'll switch this over, and we want a 99%. All right, we're not going to do anything else. Just click the compute. And again, notice here, let's see, round to 2 decimal places. All right, so this one here is a multiple choice. So this one is also asking us to interpret our results. So you have to recall, what does it mean to construct a confidence interval. So if repeated samples are taken, 99% of them will have a sample mean between the lower bound and the upper bound. This one is not true because we're not working with the sample mean. We're constructing these confidence intervals for a population mean. There is a 99% probability that the true mean confidence intervals have nothing to do with probability. So by default, the correct answer and the correct response is that a 99% confidence that the population mean, that is true, is contained between, and here we'll go ahead and what did it say, round to 2 decimal places, so 12.06 and 14.74. So if you see this question in your homework, the idea is not to say, oh, this is what it is. Just make sure that everything makes sense. Boom, got our green box, so we can go ahead and move on to the next question. So the next and final example that I would like to take a look at is sample size computation. Okay, so sample size computation, this will work fairly similar to what we did before. All right, so here we're asked a 99% confidence level requires how many subjects, okay? So we're going to need our margin of error of 2 points with 99%, assuming that the standard deviation is 14.4. Okay, and then we will take a look at this one at 95%, but again, it is not my purpose to do the homework question for you, so I'll probably just leave that second part for you. So we'll come over here to t-stats, one sample, and again we'll just choose the width sample size here. All right, so our confidence level here is 99%, so we'll put that in there. Our standard deviation is 14.4, so we'll put that in there. Okay. The width of the interval, again, we'll have to double this. This was 2 points, so we need to have 0.04. Apparently, this is a mean on percentages, or however they report back this. So if we want our to be within 2, our margin of error is going to be 2 whatever points, whatever that's supposed to mean. So again, we have to double this to 4. So we want to compute our sample size. So notice it comes back and says that we have to have 348. So let's plug this in here, 348, and do our check answer, and hopefully we get our green box, and we did. Okay, so you can go ahead and do part B. I'll leave that for you to do. And let's see, we got critical scores taken care of, we got confidence intervals taken care of, and we got sample size computation for the sample mean taken care of. So I hope this video helps you out.